Welcome and study with Tanzania Institute of Education. How are you, Form 2 student? Very good. Now please prepare your exercise book and pen so we start our lesson. Alright. I hope now you are ready to start our physics lesson. I'm ready as well. So, dear student, in our daily lives, we open and close doors or windows when force is applied to them. Again, when force is applied on the pedals of the bicycle, it causes the rotation of the wheels. In both cases, predict what causes the object to turn when the force is applied. What is the name of the force that turns the objects? Specifically, in this lesson, we are going to learn the effect of turning forces and determine the moment of a force. Learning this will broaden our understanding while using machines such as opening doors or windows, loosening up nuts from the bolt, using a spanner, or opening the cap of the bottle using the bottle opener, and many more. Forces have various effects on the body. Some of these effects include stretching, compressing, and rotating or turning. When we push an object to turn, we say that we are applying a turning force. This force is different from the regular force because instead of moving an object along a straight line, it rotates the object. In fact, the object turns about a fixed point, hence the term turning effect of force. When a force causes an object to turn, this turning effect is called a moment. This is because the turning effect allows an object to rotate about a turning point or pivot. In loosening the nut from the bolt becomes easier if one used the long spanner, since the small force will be applied on the spanner, which causes larger turning forces on the nut. But using a short spanner, large force will be used, which eventually will destroy the bolt thread. Examples of turning effect of force includes 1. When a person applies force to a spanner to rotate a nut. 2. When a person removes a bottle's cork by pushing down the bottle's opener's lever. 3. When force is applied to a doorknob and the door swings open about its hinge. And 4. When a driver turns a steering wheel by applying force on its rim. A force may be applied to make things turn around, for example, driving a screw into a piece of wood by using a screwdriver and tightening of a nut on the bolt by using a spanner. Experience shows that it is easier to loosen a nut on the bolt by using a spanner with a longer stem than using a spanner with a shorter stem. Therefore, the turning effect of a force depends on its magnitude and distance from the turning point. The turning effect of the force about a point is also known as a moment of the force about that point. The moment of a force about the point is given by multiplication of the magnitude of the force and perpendicular distance between the line of action of the force and the point. So, dear student, after understanding the meaning of moment of force, let us move on and see the SI unit of moment of force. The Standard International Unit, which basically is SI unit of a moment of force, is Newton meter, abbreviated by the capital letter N and the small letter m, where N is the SI unit of force and m is the SI unit of perpendicular distance, since the moment of force is obtained by the multiplication of force and the perpendicular distance. My dear student, now it's time for you to do exercises based on what we have learned so far, so please get prepared.
Let's study, be educated. Elimu ni kazi. Elimu ni kazi.
Now here are the questions, and I'm going to repeat them, each question twice. Number 1. Define turning effect of forces. Again, define turning effect of forces. Number 2. Write the formula for a moment of force. Again, write the formula for a moment of force. Question number 3. State the SI units of moment of a force. Again, state the SI units of moment of a force. Question number 4. A line of action of a force of 48 Newton is the perpendicular distance of 1.5 meter from a point. Now, find the moment of the force about the point. Again, a line of action of a force of 48 Newton is at a perpendicular distance of 1.5 meter from a point. Now, find the moment of the force about the point. And question number 5. The moment of a force about a point is 1,120 Newton meter. If the magnitude of the force is 5,600 Newton, find the perpendicular distance between the point of the line of action of the force. Again, the moment of a force about a point is 1,120 Newton meter. If the magnitude of the force is 5,600 Newton, find the perpendicular distance between the point of the line of action of the force. Thank you for listening. See you in the next lesson. Goodbye.
Let's study, be educated, and